Yeah, what's up, everyone? Welcome to Tech Sound Engineering. Very glad to have you guys here. So today, I'll be looking at some various type of resistors and how do we test them. Intentionally brought different type with different ohms, kilo ohms, and the rest. Okay, we have them, and also have this my board here again, so that we can use it as a case study how to use it to trace 40 resistors on our board. Okay, so we'll be looking at it together. Uh, well, one thing you really have to really understand is that resistor really resists the flow of the current, yeah, in the circuit. You understand? Because if you look at it, it says 1 over R, but don't let us go into physics and the rest, because V is equals to high R. That is your voltage, your current, and your resistance. You understand? And in terms of ohms, so you remember we have various units: the ohms, a kilo ohms, a micro, and you understand, and the rest. But we are not going there for today. So what we need to do is, how do you know when a resistor is bad? You understand? Because mind you, if you look at this board now, just the fault of one of this resistor alone will affect the activity of every other one. They will not function properly. You understand? So how do we really, you understand, so troubleshoot it and save ourselves the straight? We have a lot of approach, but one of the easiest I'll be giving to you is this, because I like keeping things very, very simple. Just set your multimeter to continuity. If you don't still know how to do it by now, check my playlist. I have tons of videos on that that will really guide you on that. So now my multimeter is on continuity. If I put it now, I should hear a sound. And mind you, all these sides are to measure your ohms. You understand? This is in terms of anything between 200 ohms downward, 2000 ohms downward, 20k, 200k, 2 million, and yeah, 2 million, yeah, ohms maximum, yeah. So these are the range we'll be using. But first, we'll first test with our continuity. If it is within the range, we can still at least have a sign that it is good or bad. So let's check. So if I'm holding one side, maybe you can see me now, and my hand is at the other one. Do you hear any sound? No sound. Any readings? No. So that is to tell you that it's beyond range, but you can't conclude yet. So increase, set this your resistor and your multimeter, set it to the highest. Start from there. So if I'm starting from there now, let's test now. If I touch it, anyway, okay. So 0.0, that means it's below that range. Let's go to 200. I'm trying to keep it very simple for you guys. So you can see this is 9.7. Okay, so let's drop it. So let's go. You see, so this is a 9.6. So approximately this is a 10k resistor. How do I know it's 10k? This is 10. This is 9.68. So if you approximately, because mind you, there will always be plus or minus. It's normal. So you see the way I started from the highest. I keep growing it till I get to the range. So it must fall between one of all this range. So if it within all those range and nothing is coming up, there is a sign for you to know that there is a problem somewhere. But this is a 10k resistor, so we're done with this one. Let me put it somewhere. Let's look for another one. I don't know the value of this. Let's see. Okay, this is 0.1, so that's to tell you it's downward. So let's test. It's still downward more. A small resistor. So if I'm testing now, so now if I look at this very well, this should be an 100 ohms resistor. 100 is 100, yeah. I don't mind the fluctuation. It's 100. Is 100 ohms. So look at it now. Why did I say 100 ohm? I'm not, the last one I said 10k. Look at the range where I am. My range is at the range of 200. You understand? I'm not unlike that one that was at 20k and it gave me 10. So 9.6, which was 10k. You understand? That means 10,000. K simply means 1,000. That is 3 digits of 0. But this is 200. You understand now? So I'm having the range of 1 something. So this is 100 ohms resistor, not 100k, 100 ohms. Is that clear now? So I believe you are getting it. So let's look for this one. If you are using a lower ohms, if it's above, it will not even read anything. So that is why I always advise to start from the biggest, the highest rating you have. So putting this here, you can see. So this is 0. So that means it's downward a bit. Nothing here. Let's go back and adjust the screen so you can see. This is 0.34 something. When you go down, no reading. Let's go a bit. How does STC? Nothing. So that means it's beyond all this rating except that, okay, within the range of 200k. Is beyond 200k. So this value is more than 200k. I remember my body seems to be 560k. So let's go to 2 million now. You can see it now. Don't mind the fluctuation. My battery is low. That's why it's misbehaving. Okay. So I remember when I bought it, it's 560k. Oh, yeah. So it's 560. So the reason why it could only read around this range was because it's, I said 560k, so it's beyond this. So it can only read around this. All these guys cannot do it. Exactly now. All right. But you are trying to trace a fault. So even though you don't get the exact value, but at least you have a very good idea that, okay, this is still good or it is bad. All right. We'll still look at the bad ones now. So I'm starting from the highest value again. Okay, this is still the same thing, the same type. Yeah, so it will not show here because it's beyond that level. So it's between the range of 200k to 2 million. All right, so those are for the good ones. Now let's look at the bad ones. Now, one thing in a panel, a faulty resistor, they are very, very easy to locate, because one thing, when you are tracing fault, first check for any form of physical damage. You understand now? Any physical damage you can see, check out for it. Once you see that is a first glance that something is really wrong. But if you look at all this, they are really still very neat. Looking into it, I see there is nothing wrong. So I can indirectly assume that all these components are still okay. But sometimes, at times, you may not have any form of physical damage. So that is when you have to start testing. So for this now, for example, sorry about this stuff. Okay. Now, looking at this one now, we don't know the value precisely, but what we want to be sure is this still good or it is bad? So I will come down to my, let's go to 2 million. Okay, let's see. You see, this is 0.000. So indirectly, this resistor is gone. I see resistance is 0. So this is a bad one. It's a good, and it's a clear indication that this is bad. So let's read it so that you clear your mind. Can say still 0. So if I vary it to my continuity, you'll see that what I will have, let's look at it. You see it. So it's a short circuit resistor already, short already. So this one is a bad one. So that is one of the ways once you test it, no reading, you are seeing 0.00. It's a clear sign. See this one, nothing, no resistance at all. But let's check further. But once you even see any physical damage on it, just change it. And see the level of burnt on it already. This one has burned. Sorry from my camera not clear. So this one is bad. You can see explosion on it. So if you check, you see it's a very big resistor, though not 100% burnt, but not a reliable one. Okay, exactly now. So now let's now look at real life application of this. Let's find the value of these resistors in these ones here. So if I take my remember it's not polarity sensitive, so I'm currently at 2 million K. So let's test You see, this is 0.000. So that's tell you it's below that area. Let's check. Okay, still below that area too. Okay, we are getting close. Okay, still slow. If I'm suspecting this should be an 100k resistor, but let's see. You can see it is 100k. So it's 100k. Let's see the second one. This is 100k. This is 100k resistor. No, sorry, 100 ohms, not k. Okay, look at where I am. It's not k, it's 100 ohms. Sorry, 100 ohms resistor. 100 ohms resistor. So let's assume we want to test this, for example, as a case study now. If I tap this two, please, see, it's not reading, but it's not a sign that it has spoiled. It's beyond that range. So let's go to 2k range. Let's check. Nothing like that. 20k range. Nothing like that too. This is 200k range. You see it. So indirectly, this is a 50k resistor. It's 50k. Yeah. I'm currently at the range of 200k. So and the last range here was 220k. So it means anything from 220.1 to 200k. So this is 50k resistor. All right. So let's check this also. Probably the same. 50k also. Let's look at this. Let's see. This value is down. Let's go to 2k. Okay, it's still down. It's not a big resistor. Since we are still down, let's go to 2k back. So looking at this now, this should be 500 ohms. Yeah, because this is 0.6. So, and this is a range of 2k. So it's not up to, it's beyond the reading. Why it's not reading at this 200k is because, of course, it's beyond it. So that's why it's not really reading. So once you test anyone, you check it. None of these is reading at all your various resistance range. That is to tell you that there is a good indication that there is a problem with that resistor. So change it. So that's just it. So there are some of these my burnt one that are still not 100% burnt, but I can see the damage on it already. So it's good I just change it out to save myself the stress of shooting and causing more issue. All right. So for those of you that are just starting electronics and you cannot really identify most of this stuff very well, don't worry. If you want me to do a video on that, drop it in the comment section, and if I see enough comments, I will use this as a case study. We will look at all the various components on it, their names, their function, and the way it really works. And if you want me to do a video on this board itself, let me know in the comment section. All right. Thank you so much. See you guys in my next video.